What if the most profound message humanity ever sent wasn't a radio signal, a satellite broadcast, or an internet transmission, but a golden disk bolted to a 722-kilogram spacecraft drifting silently through interstellar space right now? That spacecraft is Voyager 1. It has no destination, no return ticket, and it will outlive the sun itself. Long after our star is burned out and Earth exists only as scattered cosmic dust, this small machine will still be moving, carrying a fragment of who we were into a future no human will ever witness. It all began with a rare stroke of cosmic timing. The outer planets aligned in a configuration that occurs once every 175 years, making it possible for a single spacecraft to visit multiple worlds by borrowing gravity from each one. Scientists called it a grand tour. They had one window. They took it. Voyager 1 lifted off on September 5, 1977, aboard a Titan III rocket, just 16 days after its twin, Voyager 2. On board, cameras, spectrometers, plasma detectors, and magnetometers. But the most remarkable item wasn't scientific equipment at all. It was a gold-plated copper disc, the Golden Record, containing images, music, greetings in 55 languages, and a pulsar map pointing directly back to Earth. A message in a bottle thrown into an ocean with no shore. From the first second of launch, no return was ever planned. Jupiter was the first major stop. What Voyager found there shattered expectations. Winds screaming at 1,500 kilometers per hour, the Great Red Spot, a storm wider than Earth, churning with a violence that had been raging for centuries. But the real shock came from Io, one of Jupiter's moons, active volcanoes erupting in real time, sending plumes 100 kilometers into space. No one had seen volcanic activity anywhere beyond Earth before. Jupiter also delivered something Voyager desperately needed, a gravity assist, slingshotting the craft outward and accelerating it toward its next target. Saturn revealed an entirely new level of complexity. What looks like smooth, elegant rings from Earth turned out to be an intricate system of countless ringlets, gaps, and rippling waves, each one sculpted by the gravitational pull of nearby moons. The rings themselves stretch across hundreds of thousands of kilometers, composed mostly of water ice particles ranging from fine dust to house-sized boulders. The key target here was Titan, a moon larger than Mercury, wrapped in a nitrogen-rich atmosphere so thick it completely hides the surface. Its atmospheric pressure is 1.5 times greater than Earth's at sea level. Sunlight and energetic particles constantly break down and reassemble molecules, building complex hydrocarbons that rain down onto the surface. In short, chemistry that vaguely echoes the conditions of early Earth. Voyager flew past Titan at close range, and in doing so, bent its trajectory permanently outward, past the planets, toward the edge of the solar system. In 1990, before the cameras were shut down to conserve power, Voyager turned around one final time. From nearly 6 billion kilometers away, it photographed the solar system as a whole. Earth appeared as a single pale pixel, barely visible against the darkness. Carl Sagan called it the pale blue dot. Every war, every civilization, every love story, every idea humanity ever had, compressed into a single point of light. Then, the cameras went dark. Voyager pressed on, covering 17 kilometers every second, heading for the heliopause. The boundary where the sun's solar wind can no longer hold back the pressure of interstellar space. The crossing isn't a line you can see. It's a shift in particle readings, a sharp drop in solar particles, a sudden rise in cosmic rays from beyond the heliosphere. On August 25, 2012, those readings changed. Voyager 1 crossed the heliopause and entered interstellar space, the vast emptiness between stars. By late 2026, it will reach 25.9 billion kilometers from Earth. One full light day away. A signal sent today arrives tomorrow. A reply comes back the day after. But the spacecraft is aging. Its radioisotope generators lose power every year, and NASA has been methodically shutting down instruments one by one to keep the mission alive. There will come a day, expected sometime around the late 2020s, when the last signal fades. Not dramatically, just silence where there used to be data. And then Voyager will simply continue, alone, untracked, unlistened to. A relic of a civilization it may have long outlasted. In roughly 40,000 years, it will drift within 1.7 light years of a star called Gliese 445. Not close enough to be captured, just a passing glance across an incomprehensible distance. In 3 to 4 billion years, it will be somewhere in the Milky Way, its exact position impossible to reconstruct. By then, the Andromeda Galaxy will have already begun its collision course with ours, and the two will be merging into something new. Voyager will have a front-row view of two galaxies intertwining across billions of years. In 10 trillion years, 1,000 times the current age of the universe. The last red dwarf stars will be burning out. The cosmos will grow dark and quiet. Voyager will be older than almost every star that ever existed. And beyond even that, if proton decay is real, ordinary matter itself will eventually dissolve. Everything that was ever built, written, felt, or remembered, gone. Perhaps even Voyager, in the end, will come apart at the atomic level, absorbed back into the fabric of a universe that no longer resembles anything we know. But here's what stays with you. A species that had barely left its own planet decided to put a golden record on a spacecraft, point it at the stars, and say, "We were here." Not because anyone would definitely find it, not because there was any guarantee it would matter. But because looking up and reaching out is what we do. Voyager 1 didn't just explore the outer planets. It became the most distant object humanity has ever made. And somewhere out there right now, in the cold and the dark between stars, it's still moving.